Okay, so let's dive into 2.2. So last class, 2.1, we talked about something called the addition property of equality. Again, it was one of those things that you probably knew, or at least had done that before, but you didn't know the technical name. So this is the same thing. This is the multiplication property of equality. Same thing, stuff you guys have done before, but you probably did not call it the multiplication property of equality. So anyways, this is what it is. We're looking at, so this is where we got last time, and this is where I said I kind of jumped ahead, because on this one, you start off with the equation 3x plus 2 equals 17. You use the addition property of equality to subtract 2 from both sides, and then you're down to 3x equals 15. Now remember, the goal here is that, we want it to equal x, not to equal 3x. So I don't know if you guys remember from last class, but we had that one problem where it was like 3x equals 0, and I kind of talked through like this multiplication property of equality. But anyways, we're going to kind of look at it again today. So because of that, the multiplication property of equality is needed. Okay, so here is the multiplication property of equality. Just like last class, whenever I think about the multiplication property of equality, I do think about this whole balance scale still. So remember I said before in the balance scale, if you add something to this side, you have to add it to this side, or else they won't be equivalent. Same thing if you take something away from this side, you have to take it away from that side. So this is the same exact thing. So, but if you multiply something to one side, you're going to have to also multiply it to the other side. And the same thing, if you divide something by one side, you divide it by the other side. So same idea, this whole idea of like, I set them up same way with the line down the middle. I still put my little boxes around the variables. I still do them the same exact way. It's just how you solve them is going to be a little different. So let's look at an example here. So this is going to be my example. It says solve 3x is equal to 27. Okay, so again, the first thing I do, I don't know if I made this editable. Sorry. Yes, the first thing I'm going to do is put this line right down the middle, just like I did before with addition. I'm going to put my variable around 3x. Now this is where it gets a little interesting. So remember last time I talked about variables, and I kind of said this last time before. Remember, variables are loners. They don't like anything around them. They don't like numbers to the side of them or in front of them. Especially they don't like numbers that are right next to them. You know, it's the personal space thing. It's the thing that I don't like. I don't like personal. I don't like people in my personal space. That's what I'm going to say. So, like last time, remember with the addition property of equality, if we had x plus 3 equals to 7, well, to get this 3, remember we did this and drew a line around here, but to get this to the other side, remember we had to do the opposite. So here we're adding 3, so remember we subtracted 3 from that side, subtracted 3 from that side, and we got x is equal to 4, right? Here, what you have to remind yourself is what is happening between the 3 and the x. So I kind of go through. Are they being added? Well, I don't see a plus sign, right? Are they being subtracted? I don't see that. Are they being multiplied? Well, I don't see a multiplication sign, but maybe. Or are they being divided, right? So in this case, I think you guys would all agree they're being multiplied. So because of that, we have to do the opposite of multiplication, which I consider to be division. And what we're going to do is we're going to divide both sides by 3. So this is the other struggle that some students get into is they don't know, like, do I divide it by 3, divide it by 27? Like, which one am I looking for here? What I say to myself is that it's the number that's touching the x. So I honestly, I go back and I'm like, okay, remember, x likes being alone, so anything touching it, it's not going to want there, okay? So what happens on this side? So I'm looking at 3 over 3, right? What does that equal? Well, I think about fractions this way, right? So I've got my piece right here, and I've got 3 pieces shaded in. So there's 1, there's that. I think the whole is shaded in. So 3 over 3 is going to equal 1. Hopefully that makes sense. So these kind of like go away because then this becomes 1x, and then you have 27 divided by 3, and that's going to be 9. So in this case, we're going to get that x is equal to 9. And just like the last lesson, you can plug this back in there. So you ask yourself, is 3 times 9 equal to 27? I would say that it is, so we're good to go. Okay, so in this step, we're just going to think that the 3 is being multiplied to the x, so we're going to have to divide both sides to get our answer. So go ahead and try this one and give it a couple minutes. It's totally fine if you have to use a calculator as well. Okay, so I set this one up exactly the same way. Line down the middle. Divide by 15 because that's the one touching the x, right? If you need to put your box around that, that's totally fine. Do it. Divide this one by 15, and I think if I use my calculator, oh gosh, is that 5, I think? So again, in your calculator, 15 times 5, is that equal to 75? Sure is, so we're good. Okay? Oh, sorry, they kind of went through. So the solution set is 5. So again, on Pearson, I'm not going to go through the homework again, but just remember this is kind of what we're looking for, okay? All right, this one, same thing, except for there's going to be something funky about this one, so I just want to talk to you about it and kind of go through it. So again, line down the middle, box around there. I see a 4x. I'm going to divide this side by 4, divide this side by 4. Now be careful. Those are going to simplify to just x, right? Now, remember, negative 18 over 4, I'm going to leave that as negative 18 over 4. Now, Pearson, I think, will make you simplify that. So remember, I'm not a big fan of negatives, fractions, or decimals. In talking to some of the other professors, I've learned that we're going to have to deal with these things. Like, just because I'm not a fan of them, we're just going to have to deal with them. So one of those things is fractions and how do you simplify, okay? So I'm looking at 18, and this is like really the long way to go about it. But I see 18 over 4, and I want to simplify that. The first check that I always do, and this is just something I always do, is I try to decide if they're even. Is 4 an even number? Well, I know my even numbers are 2, 4, 6, 8. So yes, is 18, sure, it ends in an 8, 2, 4, 6, 8. So I can at least start by dividing these by 2. Now, is that the greatest number I can divide by? I don't know. But I know that they're both even. So at least I can divide by 2. And I think 18 divided by 2 is 9. And 4 divided by 2 is 9. So then I ask myself, well, 2 is even, but 9 is odd. So I think that's as simplified as we can get. So I think my answer is negative 9 over 2. So again, when do I know how to simplify? How do I simplify? All that stuff. So we're basically just trying to think of the largest number that goes into both these. Now, this is like a side example. Let's say that it was 20 over 4, right? I'm going to leave the negative out for now. I notice both those are even, so why not divide by 2, right? Divide there by 2, divide there by 2. So I get 10 over 2, but then I ask myself again, is that even? Sure, 2 is even, 10's even. So again, let's divide by 2 again. Sorry, it's terrible. So I have 5 over 1, right, which is just equal to 5. But, like, could I see from the beginning that 4 is the largest number that goes in there? Sure. Is it okay if I have to do this a couple extra times? I would think so, okay? So here the solution set is negative 9 over 2. All right, so go ahead and give this one a shot. Take a couple minutes, see what you get. And you're going to have to simplify. Okay, like before, line down the middle, box around there. I think this is being multiplied. I'm going to divide there, I'm going to divide there. So I get 8 equals negative 20 over 8. Is it simplified? I don't know. 8's even. 20's even. So let's start here. I think that's 10 over 4. Right? Don't forget your negative sign. Right? Even, even. Let's try it again. Even, odd. I'm good. Now, I don't know. I don't know. Yeah, I mean, there's going to be some times that you might have an even and odd and it still can simplify. But, anyways, this is a good, 10 over 5 would be one of those kind of things. So you want to, because 5 goes into it. Anyways, side note. But you just want to take it down as far as you can. And for me, that's as far as I can take it. Okay? So the solution set is that. Hopefully that made sense. Simplifying is a little bit intense, but I feel confident you guys can do it. All right, so moving forward, this is teacher example number 3. So now we've got this whole fractional coefficient. What in the what? Okay, so here's how I kind of think through this. So again, line down the middle. Probably going to take that solution word out of there, sorry. Box around here. Okay, so now my question is, what is happening between the x and the 3? Is it being added, subtracted, multiplied, or divided? Correct. It's being divided. So we have to do the opposite of division in this case, which we're actually going to multiply both by 3. So then again, those cancel, left with x, and I think that 4 times 3 is 12, and that's my solution. Can I check it? Sure. Is 12 divided by 3 equal to 4? I would say yes, so that's my solution set. So again, if you have a division problem, you're just going to do the opposite, which is multiplication, and kind of get your answer. So go ahead and try this one. Okay, again, line down the middle, bloop. That in a box. This is being divided from this side, so I'm going to have to multiply that by 4, multiply that by 4. So be careful. Remember, we haven't really talked about this, but a negative times a positive will give you a negative 24 there. Remember, if you have like signs, so 2 positives or 2 negatives, they're going to be positive when it comes to multiplication. If you have opposite signs, so 1 positive, 1 negative, or 1 negative, 1 positive, those are going to be negative. Okay? All right. So hopefully that's making sense so far. So the solution set is 24. Okay, I think this is... Oh no, we have two more types. Okay, so this is teacher example 4. So now I've got this funky thing over here, right? So again, line down the middle. Around here, now I've got a 2/5. Okay, the way that I focus on this is I take it in 2 steps. Technically, could I divide this side by 2/5 and this side by 2/5? Sure. Sometimes putting fractions in your calculator is a little difficult. You may get the right answer, especially if your calculator does order of operations. I don't know. But take it 2 steps. What's happening with the 5 here and the p? I think they're being divided, right? So just like before, I'm going to multiply that side by 5. I'm going to multiply that side by 5. This time, I get 5 times 2, which is 10 over 5, which still leaves me with 2p. Okay, so basically the things that cancel are there, but your numerator is still there. And I think that 4 times 5 is 20. Okay, so the difference here is that I don't have a numerator of 1. I have a numerator of a different number. So that's going to kind of change things up. And then here, okay, well, I'm back to my thing again. I still got my equal sign. I'm going to put this around here. I think the 2 is being multiplied by p, so divide that by 2. Divide that by 2, so I get p equals 10. And I think that's my answer. Okay? So that was kind of funky in the sense of, like, you kind of have to do it 2 steps. And I always start with the division part first. Could I have done it the other way? I don't know. Let's see. I'm kind of intrigued now. Let's say that I wanted to divide both sides by 2 first. So I get 1 over 5p equals 2 times 10, p equals 10. Yeah, that was a little trickier because you got to remember this 1 up here, but I guess you can do it either way. But I normally start with the division first. All right, go ahead and give this one a shot. Okay, so line down the middle. This one, sorry, I'm going to put a box around here. Now, this is where it gets a little tricky. So you either have to multiply by a -3, which I would do. So you're left with a 2t equals, remember, a negative times a negative is a positive. Divide by 2, divide by 2. T is equal to 18. That's what I would do. Or you can leave the negative with the 2, and then here divide by the negative, and you still get there. Either one works. So hopefully that made sense. So what I'm saying is if you have a negative, you either have to multiply by a negative or divide by a negative. You can't do both. If you do both, then you're basically canceling it out. Okay? All right, last example right here. And it says combining like terms when solving. All we're going to do here is, again, remember this line's right down the middle. I've got 5x there, negative 7x there. I think that's going to combine to a negative 2x is equal to negative 10. Divided by negative 2, divided by negative 2. So x is going to equal 5. Okay, so then when we're just combining like terms first, and then realizing that we don't have a 1 in front of that x, so we're gonna do our thing. So go ahead and give this one a shot really quick. Okay, again, line down the middle. Combine these two. I think you're going to get negative 5r is equal to 20. Divide by negative 5. Divide by negative 5. You get r equals negative 4. Should be your solution.